Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve an application of integral problem. As per the problem, smaller area enclosed by the circle x squared plus y squared equals 4 and the line x plus y equals 2 is, we are given 4 answer choices. We have to choose the correct answer choice. In this problem, we have to find the smaller area enclosed by the given circle and the given line. The first step is to identify the smaller area enclosed by the circle and line. For that, we should graph this circle and line. The center of the circle is 0, 0 or origin. The radius of this circle is equal to square root of 4, which is equal to 2. So this circle will cross the x-axis at 2 and negative 2 and y-axis at 2 and negative 2. We can draw the circle. Now we can graph the line x plus y equals 2. We can find its x and y intercepts. For x-intercept, we should replace y with 0 and solve for x. I get x equals 2. So its x-intercept is 2 or 0.2, 0. Now we can find its y-intercept. We should replace x with 0. I get y equals 2. So this line has y-intercept at y equals 2 or 0.0, 2. We can join these points. This is the graph of line x plus y equals 2. We have to find the smaller area enclosed by the circle and this line. That smaller area is this shaded region. We have to find the area of this shaded region. As you can see in this graph, area of shaded region is equal to area of the quarter circle in quadrant 1 minus the area of triangle. I can label the corner points of the triangle A, B, C. So if we subtract these two areas, we will get the area of the shaded region. There are two ways to calculate the area of this shaded region. The easier way is to calculate the area of the quarter circle using the formula for circle, and then calculate the area of the triangle using the formula for area of triangle. As you may know, the formula for area of a circle is pi r square. So area of quarter circle is pi r square divided by 4 minus area of triangle ABC. The formula for area of triangle is base times height divided by 2. For the circle, the radius value is 2. For the triangle, the length of the base, which is side BC, is 2 units. The height, which is side AB, is 2 units because this is a right angle triangle divided by 2. Now we can simplify this expression. 2 squared is 4. I get pi minus 2. This is the area of the shaded region. The other way is to use integration to find the area of the shaded region. As you can see, this shaded region lies between x values 0 and 2. We can use definite integral to find the area of the shaded region. For this shaded region, 0 is the lower limit and 2 is the upper limit along the x-axis. We can use integration to calculate the area under the line x plus y equals 2 from x value 0 to 2, the area under the circle from x value 0 to 2, and then subtract these areas. If we want to use the x values 0 and 2 as the lower and upper limits, we can write the expression for area of the shaded region as area under the circle from x values 0 to 2 minus area under the line from x values 0 to 2. In the first definite integral, we have to do the substitution for y from the equation of the circle. We should isolate y. In the circle equation, I get y square equals 4 minus x square. Next, we can apply square root to both sides. As we can see in the graph, we have to calculate the area under the circle in the first quadrant, so we can ignore the negative case when we apply the square root. So for the area under the circle, we should use y equals square root of 4 minus x squared. For the line, we can isolate y from the equation of the line. I get y equals 2 minus x. Now we can do the substitution in the area equation. Now we can calculate these two definite integrals. For integral of square root of 4 minus x squared, we can use the formula integral of square root of a squared minus x squared is equal to x over 2 times square root of a squared minus x squared plus a squared over 2 times sine inverse x over a plus the integration constant c. For definite integrals, we will ignore the integration constant. In our expression square root of 4 minus x squared, a squared is equal to 4. So a is equal to 2. So the definite integral is x over 2 times 4 minus x squared plus 4 over 2 sine inverse x over 2 with the bounds 0 to 2. Now we can find the integral of the second expression 2 minus x. I get 2x minus x squared over 2 with the lower limit 0 and upper limit 2. Now we can apply the limit. I get 2 over 2 and then 4 minus 2 squared plus 4 over 2 can be reduced to 2 and then sine inverse 2 over 2 minus 0 over 2 times square root of 4 minus 0 square plus 2 and then sine inverse 0 over 2. Next we can apply the upper and lower limit to the second part. I get minus 2 times 2 minus 2 square over 2 minus 2 times 0 minus 0 squared over 2. Now we can evaluate this expression. In the first part, 2 over 2 is 1. Square root of 4 minus 2 square is equal to 0. Sine inverse 2 over 2 is equivalent to sine inverse 1, which is equal to pi over 2. In the second part, 0 over 2 is equal to 0, so that term goes away. Sine inverse 0 over 2 is equivalent to sine inverse 0, which is equal to 0. In the next part, 2 times 2 is 4. 2 square is 4. 4 divided by 2 is 2. In the last part, 2 times 0 is 0. 0 square over 2 is equal to 0. So we are left with just 0. 1 times 0 is 0. So that term goes away. 2 times pi over 2 is equal to just pi. 0 plus 2 times 0 is equal to 0. 4 minus 2 is 2. 2 minus 0 is 2. So we get A equals pi minus 2. This is the area of the shaded region. We get the same answer that we got from the first method. So the answer should be option A. This should be the final answer for this problem. So these are the steps you have to keep in mind to solve this problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.